Let's start with an important concept of maxima and minima. See, as the name suggests, maxima is going to be the highest value of function and minima is going to be the lowest value of function. So from now, we'll be finding the highest as well as the lowest value of a function. Let's take a function given by y as f of x. So what I'm trying to say is, let's take an x-axis, take another y-axis, and take this function. And let's assume that we are drawing its graph. Hypothetically, let's say the graph goes like this and then comes like this and then comes like this and then goes like this and then comes like this. Now from this graph you have to make a judgment. See, the graph starts from a point which is very deep, so that might be a minima. Now the graph keeps on increasing and then takes a turn. Now when it takes a turn, after increasing it starts to decrease. See, if something first increases and then starts to decrease, then that point may be possibly a candidate for maxima. So this point over here may be a possible candidate for maxima. Then the graph further decreases, keeps on decreasing, and then suddenly it starts to increase. The point at which it takes a turn is a very deep point, which may be a possible candidate for minima. Then again it keeps on increasing, takes a turn, which may be a possible candidate for maxima. Similarly, this may be a possible candidate of minima. And beyond that, the graph keeps on increasing, and so on. It keeps on increasing. So this may be a possible candidate for maxima. So in the whole graph, we are just finding the possible candidates which can be maxima or minima. And we have shortlisted these points. Firstly, we call these points as critical points. And then we have shortlisted the critical points as 2 points. One as endpoints and second are known as turning points. As you can see, the graph starts from this position and ends over this position. So the two corner points over here are known as endpoints. This is one of the endpoint and this is another endpoint. Endpoints are the points where either graph starts from or ends. And second sort of points are called turning points. Turning points are such points where graphs takes a turn. Over these points, graph takes turn. Now, if you see something about this turning point, all are U-shaped. All these points are U-shaped. If all these points are U-shaped, there is something special about them. That if I draw tangent at these points, then the tangent at all these points, as you can see, is going to come out horizontal. So at all these turning points, tangent is horizontal. If tangent over here is horizontal, then theta must be equal to 0, where theta is the angle of tangent with x-axis. Theta must be 0. If theta must be 0, then tan theta must be equal to 0. And tan theta is slope. So slope of tangent at these points must be 0. Now in differentiation, we learned one fact that slope of tangent at a point can be given as dy by dx. And at these points, dy by dx must be 0. So to find turning points, we need to go with dy by dx must be 0. This is the condition to locate turning points. So in this question, we have critical points. Critical points include endpoints and turning points. Endpoints are the points where either graph starts from or ends at, and turning points are the points where dy by dx is equal to 0. Now, once we have the critical points, what we do is, let's say we have these critical points x1, x2, x3 over here till xn. So from there, we calculate y1, y2, y3, and so on up till yn. That is value of y at all these points. Clearly, highest is going to be maxima and lowest is going to be minima.